The most mysterious things we'll ever know in the universe is our brain. What I imagine happening in as early as 10 years. Walking around with a smart headset that can not only measure your brain activity from individual areas at a very high accuracy, but also communicating with each other in a better, more effective way, to using prosthetics, drones, or other external devices around us. Hi, my name is Mehmet Günal. I'm the CEO and co-founder of Neurotech. We are building the first dedicated instrument for this new pioneered neuroimaging modality called fast optical signal.
Mehmet, you started as an electrical engineer. Why neuroscience?
I came to the United States about 22 years ago to study electrical engineering. My ambition was to get the best education I can, and I saw this video as in one of my psychology 101 classes as an elective course as an engineer. And the video was from these 60s. They implanted this little switch with an electrode later.
In a cat.
In a cat. With the switch on, you can stimulate its amygdala to initiate fight or flight mode. I looked into more psychology, took more classes in neuroscience. And as I wrapped that research, there was this pioneering lab at the University of Illinois at Urbana-Champaign, where we are at Beckman. The lab was looking for a brain-computer interface expert. I applied. Within 2 weeks, I was accepted to the position, and I moved across the states. You know, the methods that were pioneered in this lab, how to put these optodes onto a helmet, and how to build these headsets. All of those were provided to me as a resource, and with the guidance of our co-directors, I started this experiment, collected data, and then when the project wrapped after 2 years, I became an expert in this instrument itself that we use, which was apparently a 25-year-old instrument that was designed here in Urbana-Champaign at ISS. For the past 50 years, we are stuck with these methods. You have EEG on one side, very temporally accurate, millisecond level brain activity, but these are brain oscillations, which really doesn't tell us much about where the signal is originating from. But on the other scale, we have, of course, fMRI that I learned more about, and it's all about highly precise sub-centimetric millimeter level accuracy for where the signal is happening, but it takes about 5 to 10 seconds to resolve that signal, because of hemodynamic response, because of oxygen consumption taking too long. And therefore we have these two ends of the spectrum that we have in terms of neuroimaging modality, and our biggest pain, biggest challenge is this trade-off. What fast optical signal therefore can provide is that future where we are imagining now the telepathic use cases, where you imagine a thought emerges in your brain and we can pick up those activities on the cortex layer and then find ways to meaningfully understand the brain and how it communicates with each other in this millisecond level. Because this frequency domain system can send light that is modulated at a very high frequency at the level of 110, 140 megahertz. And that gives us this ability to see the fast changes in the neuronal membrane potential. And that shift is really what causes us to be able to detect this fast optical signal. So one of the things we are innovating in our new head cap is having these 3D printed capsules that actually have the best contact for the source and detectors when they are engaged, when they're on the scalp. The hair, the skin color can be an issue, but then you can actually move the modules from one area to another. Think of it like a Lego piece where you can just plug one and then put it into another one.
We're talking brain Legos.
Brain imaging Legos, where you can actually individualize custom areas that you can measure at any given time.
Every once in a while, a revolutionary product comes along that changes everything.
Describe the world 10 years from now, when all of this has happened.
More ways to engage with our brain. We can garner so much out of it in terms of raw data, especially with our neuroimaging modality and this instrument that we are developing. There's so much data that we can put through AI and find out patterns that otherwise we would never find 5, 10, 20 years ago. Moreover, be able to interface each other, ourselves, with other people, but also other things around us. The kind of thing that happens with the smartphones where, just like Steve Jobs, putting it out there and then crowdsourcing with Apple Store and turn that into telepathic use cases we call neuro apps, with all that neuro data available to them. So now we are taking that interface using your fingers, touch screens, interfacing to the origin of all that, which is our brain, our neural activity. What I envision eventually that can happen is with this kind of a technology where we can now tell better what your emotional state is at any given moment. And your agent, AI agent, can pick up on this, and now suddenly we're full of empathy, we're full of understanding of each other. There's always a period when we innovate first, where we expand in all the applications, all the different use cases, all the benefits and destructive ways we can use it. But our goal is to make sure that we are not using this to abuse or expose people to their weaknesses, but to benefit of the individual.
Make us happier.
Make everyone happier is the goal, yeah.